Okay, 8th hour. So, a lot of you guys are gone on track. Fortunately, we've got videos we can learn from, right? All right, let's give them some encouragement. Sarah, tell them they can do it. Tell them. We'll talk. Come on, Jason. Tell them they can do it.
You can do it.
Wow, did you even hear that? Okay, all right. You guys can do it. All right. So, here we go. We're going to take baby steps right away because they can't hear me, or they can't see me. So we got to make sure we're explaining everything nice and clear. We are solving trig equations. This is a worksheet. Whoa. Solving trig equations. You will be very good at this, better than we were last year. This is something you will use. Very important that we do a good job of this. This is going to tie the entire unit together, and we're going to have good times with it. So let's start here. It says 2 sine of theta minus 1 equals -2. As you look through your packet, we're going to get eventually to problems that look like this. Say 3 tangent squared of theta minus sine of theta plus 4 is equal to 16. You know, you're going to know how to solve stuff like that. So we're going to start with basic stuff and move to more difficult stuff. Follow the steps one by one. You'll be good to go. 2 sine of theta minus 1 equals -2. We start by solving for sine of theta. Okay? What do I do first? I add the 1. I get 2 sine of theta is equal to -1. Why? Because I added 1 to both sides. Got to remember there, you can't see me. Okay. Now what do I do? Divide by 2. And I get sine of theta is equal to -1/2. Pause. If you look at your unit circle sheet, which I will bring up so that we can tie all this together. Okay. Everybody got this? If you look at this sheet, unit circle basics, we can see by looking at it that sine is equal to 1/2 at 210 degrees, -1/2 at 210 degrees, and at 330 degrees, correct? Now you won't look at your graphic organizer for this. We're going to start by doing this on your calculator. So I'm going to show how you come up with the 210 and the 330 on your calculator. Okay, so that's one example. So we've located those. Now for this purpose, we're going to solve for theta given 0 is less than or equal to theta, which is less than or equal to 360. So we're going to put our answers in degrees for today. We could change that and say 0 is less than or equal to theta, which is less than or equal to 2 pi, and then we would be putting them in radians. But we're going to solve for degrees, and we're just going to stay between 0 and 360. So we've already found it, right? 210 and 330. Here's the basic process. Here's what you do. You need to draw this just about every time. This is going to be helpful to you. I draw the quadrants to identify which ones I'm looking for to satisfy the value of sine. Is sine positive or negative? So which quadrants am I referring to? First, second, third, or fourth? Third and fourth. Here's what I do. I draw a reference angle in the third quadrant and in the fourth quadrant. A reference angle is the angle between the terminal side and the x-axis. So I'm looking for those two. Does this make sense to you? That's going to be 210 and this one's going to be 330. Okay, so let's see how our calculator can tell us that. Take out your calculator, which you probably already have out. I don't because I got 48 things open on my stupid computer. Okay. Where are you? Okay, here we go. Got it. First, we go to mode. We make sure we're working in degrees because for this time, I said we're going to solve in degrees. If it was radians, then we would switch it over. Everybody good there? I quit. I go sine inverse. But I am not going to plug in -1/2 because a reference angle is always between 0 and 90, correct? So I'm just going to plug in +1/2, 0.5. And I get 30. Now, is 30 degrees one of my answers? No, it's not. But it is the reference angle for both 210 and for 330. So why was the negative important? Exactly. The negative told me I was working in the third quadrant and in the fourth quadrant. Okay, quadrants 3 and quadrants 4. That's why I used the negative. I then used the 30 degrees to determine the angles based off of their reference. So I'm 30 degrees past 180, which is what? 210 degrees. I am 30 degrees behind 360, which is 330 degrees. So in this situation, we have two solutions, 210 and 330. No, sometimes you have none, sometimes you have one, sometimes you have two, sometimes you have three, sometimes you have four, sometimes you have five, sometimes you will have 6. Could be, but I won't give you any of those. We'll probably top out at 6. You don't have to do this graph every time, but I will tell you, as soon as you start to have struggles, I will say, where's your graph? Because that's generally where people have struggles, is trying to figure that piece out. Now, if you could do that in your head, that's just fine. You guys go ahead and do it. But that's my recommendation. We set it up like that. Okay, let's try a couple more. 5 cosine of theta minus 6 equals -2. What do I do? Add the 6. 5 cosine of theta is equal to? Divide by 5. Cosine of theta is equal to 4/5. Which quadrants am I referring to? One and 4. Because cosine is positive in the first and the fourth quadrants. On the right-hand side, cosine is positive. So I now take out my calculator. I want to identify the reference angles. So you guys maybe are used to this value. 4 divided by 5. We should get about 37 degrees. 36.87. What is one of my solutions? How do I find the other one? I subtract from 360. Very good. 360 minus 36.87. So that's 360. What do you get, Larry? Already got it. Good. You want to try next two on your own? Go. What's that? Yeah. We'll get there. Try next one on your own quick, and we'll move on. Pause it. Okay, here we are. So did you guys come up with tangent theta is equal to 1/3? If tangent theta is 1/3, then I know I'm working in which quadrants? First and the third. Okay? Now, always draw your reference angles between the x-axis and the terminal side. Sometimes people will put a reference angle here, like 50 degrees here. No, that's completely wrong. You can't do that. It has to be between the x-axis and the terminal side. When you inverse tangent of theta of 1/3, what do you get? 18.43. So this is 18.43. So you're 18.43 past 180, and you're 18.43 past 0. So your angles would then be 18.43 degrees and 198.43 degrees. Are there any questions? Not too bad so far, is it? Well, so you're saying it's going to get confusing. Okay. Let's do a couple others. Let's do number 6. Negative 5 secant of a plus 4 equals negative 2. What makes that different? Secant. So what I'm going to do is solve it just the same. I'll subtract 4 from both sides. I get negative 5 secant of theta is equal to negative 6. Divide by negative 5. I have secant of theta is equal to 6 over 5. Larry's a genius. So, exactly. Secant is the reciprocal of cosine. So what we do is we switch this to cosine. Basically what we do is we take the reciprocal of both sides. I'm going to write it down so 8th hour can see. I did the reciprocal of that side. So I do the reciprocal of that side. It's a legal operation to do in mathematics. We get 5 over 6. Well, now it's easy, right? Piece of cake. Upside down. Okay, which quadrants? 1 and 4. Draw my reference angles. I inverse cosine of 5 over 6. Somebody give me a number. 33.56. So 33.56 is one of my angles, correct? And then what did you have, Sid? You got 326.44. Good job. All right. Anything else? Okay, let's try a couple harder ones. Okay. Number 9? Okay, number 9. We have negative 2 cosine of theta plus 9 is equal to 7 cosine of theta minus 2. All we're going to do is just combine like terms. So I'm going to subtract 7 cosine of theta. And I get negative 9 cosine of theta plus 9 is equal to negative 2. Now what? Subtract the 9. Negative 9 cosine of theta is equal to negative 11. Now what? Divide by negative 9 cosine of theta is equal to 11 over 9. But what? Say it, say it, say it. It's more than 1. Remember yesterday we were talking about arc sine, arc cosine, and we looked at its domain. And the domain for any arc sine or arc cosine function is going to be negative 1 to 1. You can't take the inverse cosine of 11 over 9 because the maximum value of cosine is 1 and the minimum value of cosine is negative 1. So therefore we have no solution. No. Tangent, you can inverse any number and get a result. Sine, right, bigger than 1, less than 1, negative 1, then you can't do it. So sine and cosine have those issues. No, because it's secant, and when you take the inverse, it'll be okay. All right? Okay. Flip it over. Let's look at 15. I'll let you guys get some work done here on your own. We'll should be okay after this, I think. What's different about 15? It's squared. You know, just pretend like it's an x squared. Okay? We're going to solve it just the same. What do you think we do to both sides first? We add the 2. And I get 4 tangent squared of theta is equal to 4. Not yet. What do I do now? First, divide by your 4. In that case, yes, it would work to square root both sides, but normally you wouldn't want to do that. So I get tangent squared of theta is equal to 1. Now I'll take Larry's advice, and we will square root. When I'm solving for a variable and I take a square root, I have to list the positive and the negative. Very good. So tangent of theta is equal to plus or minus 1. Positive or negative 1. Well, boy, what I got to do now is I got to list. Megan, what are you thinking? 4, very good. 4 angles, because tangent is positive in the first and third, and it is negative in the second and fourth. So I have 4 reference angles that I'm drawing here. What is tangent inverse of 1? 45. Yep. Very good. So your answers are 45 degrees, 135 degrees, 225 degrees, 315 degrees. See how that works? Okay, let's try what? Let's try one more. Let's try 18, and then you'll see some of the other tricks of the trade. Okay, so when you look at these problems, it's important, again, to stop thinking of it as tangent squared. Let's pretend it looked like this, people. How would you solve that? You'd factor out an x. Exactly. If you were going to solve this equation, you would factor out an x, and you would get 2x plus 1 is equal to 0. So you would get x is 0, and you would get negative 1/2. So we're going to do the same process here. What can we factor out? Because it's equal to 0, we will use the zero product property and start factoring. So let's take out a tangent. So I have the tangent of theta times 2 tangent of theta plus 1. See how that represents the equation that I have up above? So now, remember what you did. You guys are used to just looking at, say, oh, that's the answer. What we really do from up above is we take the first term and we set it equal to 0, and then we take the second term and we set it equal to 0. That is the process that we use, right? So let's use that same process here. Tangent of theta equals 0. That is my first equation I need to solve. Then I take 2 tangent of theta plus 1, set it equal to 0, and solve. Where is tangent equal to 0? Let's see, that's not a positive or negative question, is it? It's just where is it equal to 0? Where is it equal to 0? 0, 180, and 360. Nope. The direction said that we go between 0 and 360, and we include both 0 and 360, so we'll list all 3 of them. And then we have 2 tangent of theta plus 1 is equal to 0. So, right, we solved this like we did the very first stuff. We subtract the 1. We get 2 tangent of theta is equal to negative 1. We divide by 2. Tangent of theta is equal to negative 1/2. It's negative in which quadrants? The second and the fourth. Very good. So I have reference angles in the second and the fourth. If you tangent inverse 1/2, 26.56. So I'm going 26.56 behind 180, which is 153.43 degrees. So I'm adding that to my list up there. If I go 26.56 behind 360, .44 degrees. Hold on, we got 3 questions here. So first question, Elizabeth. Oh, very good. Okay, So Elizabeth's question, this is an excellent question. Can it be 90 plus? Remember, we never focus on 90 degrees or 270 degrees in these problems because those refer to the y-axis. And with reference angles, we are always referring to the x-axis. So, no. Stay away from that. There's another question. Okay, so how many solutions did I have? 5. Let me flip it over so we can see. I can see where we're headed. Can I just do one more? I just want to do one more. One more. We'll do, and then you guys, you'll be really set. I would just like to get a little bit further with you guys because I feel like they'll be a little bit more lost without me being there. So you guys would have something to work on as we move forward. We'll do one last one. All right, how about this one right here? 2 tangent squared plus 9 tangent plus 10. Very good. Exactly. This looks like 2x squared plus 9x plus 10. So there are times you could use the quadratic formula. I'm going to just try to give you ones that will factor in this scenario. So we'll factor this to be 2 tangent of theta. Tangent of theta. It's all going to be plus stuff. Very good. So I've got 2 tangent of theta plus 5 and tangent of theta plus 2. Now you just solve them separately. So we've got 2 tangent of theta plus 5 is equal to 0. So 2 tangent of theta is equal to negative 5. Tangent of theta is equal to negative 5 halves. Tangent can achieve positive and negative values bigger than or smaller than 1 or negative 1. And then this over here, we got tangent of theta is equal to negative 2. So which quadrants are you working in if they're both negative? They're both in the second and fourth. So you got 2 sets that are in the second and the fourth. Did you inverse 5 halves? What'd you get? 68.2. Would you inverse 2? $63.4. So, again, you want to go 63.4 behind 180 and 63.4 behind 360 and 68.2 behind 180 and 68.2 behind 360. And why don't you start rattling off some answers for me? 111.8, 291.8, 116.6, 296.6. So you have 4 solutions. You have an infinite number of solutions, but those are the solutions that exist between 0 and 360. Now, final question is this. When you guys were doing the process here and you were inversing, why weren't you typing in the negative when you did your inverse? You're just finding the reference angle. Why the negative then? What does the negative do for us? Tells us which quadrants we're working in. That's it. You guys can literally, you made quick work of that, you guys. So go to work. You can, yeah. Yeah, I'll answer a couple questions on yesterday's assignment. So for 8th hour, you guys can continue working on this sheet then. Do the problems you can do. Remember, we started easy at the beginning, so go back to the beginning if you need it. But I'm going to look at, problem 37? Is that what we're doing? Okay, so I'm going to look at problem 37. What? Yep. Problem 37 off of yesterday's assignment. Can you read it off to me? That's what you have? Okay, so we want to evaluate that. That's not too bad. I'm first going to identify this as opposite over, adjacent over hypotenuse. I'm an idiot. There we go. We got our triangle. I'm going to put theta there because that's where I want it. The adjacent, that's the opposite. The adjacent is 3. The hypotenuse is 5. What's the opposite? 4. This is 3, 4, 5 special right triangle. Pythagorean triple, which you guys have memorized. You're fascinated with. What if I told you that in my spare time I come up with Pythagorean triples? Good times. All right. Don't judge me. All right. So if we follow along here, if I cosine inverse 3 over 5, just this part right here, what do I come up with? If you cosine inverse anything, or sine inverse anything, or tangent inverse anything, what does it give you? Theta. It gives you the angle, right? I don't care about 53.9 or whatever it is. 53.1. What I just care about is it's going to give us this angle. Now, Larry's exactly right. This angle is approximately 53.1 degrees. That doesn't really matter to us because we are just going to use these pieces to write a new ratio. So what I have here now is I have the sine of 2 times theta. Hey, wait a minute. That tricky Mr. Gens, he gave us a double angle formula, didn't he? He said that sine of 2 theta, which you guys have memorized by now because you bought yourselves a bunk bed, you posted these on your ceiling so you could look at them before you went to bed at night. All right. So you memorize that sine of 2 theta is 2 sine of theta cosine of theta. It's an important one to try to remember. Yeah. I was in Spanish yesterday, and in order to memorize vocab, what the heck did you guys use? And flashcards. I'm going to start making you make flashcards of trigonometric formulas. Oh, yeah. We're doing it. All right. So, I have 2 times. The sine of theta is going to be the opposite over the hypotenuse. What's the opposite over the hypotenuse? 4 over 5. Cosine of theta is going to be 3 over 5. And so this is 2 over 1. Multiply the bottoms, you get 25. Multiply the tops, you get 24. Bada bing, bada bam, bada booski. Piece of cake, upside down. Yeah. 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 Wow. Okay, I need to explain this to YouTube Nation. Alex Hagen got a piece of pie that was like a cake, and it was in a styrofoam container, and it was warm. When it closed, it stuck to the top. So when he opened it, it turned upside down, and he had upside down cake. And it was actually pie because it was for Perkins, and so therefore it reminded him of math, and the whole world came into one. And the lion laid down with the lamb, and the world was in perfect harmony at that point, right? 38. Sure. Yeah, read it to me. I'm on a roll. Five over 13. Sure it's not 12? No, it's just they would have made it a lot nicer if we could have done. I guess it doesn't really matter. We don't have to use the hypotenuse in this scenario. So, well, I don't know, actually. Okay. Sure. So it's the same type of process. I make my triangle. I have theta. And 5 is the opposite. 13 is the adjacent. How do I figure out the hypotenuse? Pythagoras. Square root of 194. Is that right? Colin says yes. Colin's pretty smart. All right. All right. Oh my gosh. I'm just going to go home right now. I'm going to pair up everybody. All right. It's like, that's what I'm going to do. Next year, pre-calculus, here's what we're going to do. First day of calc, we are all going to sit down together. We're not going to do any calc the first day. We're just going to look at the pre-calc group, and we're going to pair them up. And we'll just sit them next to each other. And we'll say, you don't have a choice. This is your math group. This was your AccuPlacer score. You're not compatible with others. Just buy the dress and the ring right now. Okay? All right. Oh, gosh. All right. They are so tired. Like, 8th hour gets here. I feel so bad for them because, I mean, it's a fun class, but they're a great group of kids. But I'm telling you guys, they are tired a lot of days. I mean, it's like 8th hour is like, holy cow, now I got to learn about arctangent. It's challenging. So 8th hour, hang in there, guys. You guys are doing great. What if I tangent inverse 5 over 13? What do I get? I get theta. So this equation becomes tangent of 2 theta. Well, what's your double angle formula for tangent? What? No, that's this. Yeah, you're right. Okay. So I got to do 2 tangent of theta. What's tangent of theta? Tangent of theta is 5 over 13, right? So I'm going to get 2 times 5 over 13 divided by 1 minus 5 over 13 quantity squared. The rest is algebra. You go ahead and do it on your own. Oh, all right. That's the part you're having problems with. All right, we can do it. So we get 10 over 13 on top, right? And on the bottom, we have 169 over 169 minus 25 over 169. So I just wrote 1 as I renamed it. What's 25 minus, or 169 minus 25? So I got 10 over 13 over 144 over 169. Multiplied by the reciprocal, 169 over 144. Let's see, the 10 and the 144 reduced to 5 over 72, and the 169 over 13 reduces to 13 over 1, and I get 65 over 72. Bada bing, bada bam, bada booski. I do not have an answer key for this worksheet because I am lazy. We could do that. All right. Adios, 8th hour. That's Spanish for goodbye. Anybody want to say bye to 8th hour? Larry will. All right. This is goodbye time from Larry.
We're better than you.
Whoa! Whoa, that's a little trash talk. Zach, what do you have to say to them?
I agree.
Whoa, he agrees. 8th hour, you guys had it. So those in 7th hour Spanish, I sure enjoyed your guys' class yesterday. You got a great teacher, Miss Brownlow. Maybe someday I'll be like her. You know, she had a math major. Oh, yeah. Oh, yeah, she's super smart.